Hi friends, welcome back. Today we're talking about evaluating logs without a calculator. I love logarithms because if you haven't yet learned why logarithms are important, let me give you a quick example. For example, if we have something that looks like this, 5x equals 25, you could probably look at that and say, I can figure that out because 5x equals, and I know 25 is 5 squared. And then if you cross these guys out, you'll see that you have x equals 2 because that would make that statement true. I would be able to put a 2 into here. You can go back up and double check. 5 squared gives you 25. Now, if I give you something that says 5x equals 26, you'll look at that and you're like, there is no pretty number that I can use in order to get an x there that would be like a whole number, an integer, something that would be helpful. So we use logarithms in order to find these out. Before we can go into logarithms though, you've really got to understand exponents and evaluating logarithms that have like nice friendly numbers. And what do I mean by friendly numbers? I mean that they're very nice to you. Actually, no, you're nice to them because they are numbers that you start to see over and over again, and you gain some familiarity with them so that when you see it, you're like, oh, hey, that's something useful and friendly. With that said, here are your friendly numbers. Write these down. And I know you're looking at me thinking, I already know these by heart. And if you do, great. But if you don't, you need to write them down. This is my way of emphasizing you will definitely need these. I promise you're going to want to know these like the back of your hand, because then when you see them, you will think instantly, hey, I happen to know that 8 is 3 cubed. And you can straight away jump right into that. It will help you solve these much, much easier. So let's talk about that when we, let me get a different color than green. Colors are important. All right, so let's talk about that with these examples all right here. We've got 2 examples here. So if I wanted you to evaluate this, actually this should say log base 7, I'm sorry. Log base 7. Let me rewrite that. Log base 7 of 49. I just realized I made a mistake there. So looking at this guy, if I wanted you to evaluate this, yes, you could put this into a calculator. However, 2 things. One, your calculator probably only does base 10, and this is base 7. So you've got some finessing to do in order to use it in your calculator, which we'll talk about at a later date. In the meantime, though, this is a friendly number. So when you're trying to evaluate a logarithm, you first want to see if it's friendly. And the best way to do that is throw like an x on the end here. So we're going to say log base 7 of 49 equals x. And what that means is we can now use, if you remember, switching between logarithmic and exponential form. In logarithmic form, what we can use is our snail. This to this power equals this. So we have 7 to the x power equals 49. Now, looking at that, you think 49 is a friendly number because you know your perfect squares. So you say, okay, 7x equals, and instead of 49, we're going to say 7 to the second power, 7 to the second power. And now that you look at that, it's easy to see what x equals. X equals 2. Bam, you have just evaluated that without a calculator. Pat yourself on the back because you're doing things in your head. It's wonderful. Let's try it with this guy here. Log base 1/2 of 8. And now again, it's helpful to slap on an x here just to show. And let's go ahead and use our snail or our scorpion. I've heard it called both. What that means is we're going to take 1/2 to the x power equals 8. Okay, so you're going to look at 8 and you're going to say, hey, that's a friendly number. I happen to remember that that is 2 to the 3rd power. Let's say that you don't remember it's 2 to the 3rd power. You're going to need to do some side work. 8, break that down into its prime numbers, 2, 4, 2, 2. So we have 2, 2, and 2, which means we have 2 to the 3rd power. So we now know that 1/2 x equals 2 to the 3rd power, 2 to the 3rd power. Now, the other thing that we can do is, remember, there's a couple different ways to do this, and this is actually why I love exponents, because you can, and logarithms, because you can do them multiple ways. But let's say this 1/2 to the x power. Remember, that's really 1 to the x power over 2 to the x power, right? Now, the 1 to the x power doesn't even matter because it's always just going to be a 1. This 2 to the x power here, if I move this up now, equals 2 to the 3rd. I should write that. So if I move this guy upstairs, I am changing that attitude to make it negative. So now I have 2 to the negative x power equals 2 to the third. Now that I have these same bases here, I can cross those out for now and say negative x equals 3. Divide both sides by negative 1, and you have x equals negative 3. Let's go back and double check that. 1/2 to the x power. So I'll use a different color so you can see. Check, check. We got 1/2 to the negative 3 power. That's going to be 1 to the negative 3 over 2 to the negative 3. Remember, negative exponents do not affect the negative of the base. It only affects the attitude. So those negatives, we got to flop them around. This is going to be 2 to the positive over 1 to the positive 3. Now 1 to the third is just 1, so I can get rid of that. 2 to the third is 8, and sure enough, that's what we started with, so we have solved this or evaluated this correctly. Let's try some others. All right, so we've got these guys here. Evaluate log base 3 to the 1 over 27th. To 1 over 27, or of 1 over 27. Words are hard today. Okay, so we're going to throw an x on the end here, use our little scorpion snail to say 3 to the x power equals 1 over 27. You can either side work and break down 27, or you can say, hey, I have remembered my friendly numbers, and so instead I know that 27 is 3 to the third. Okay, so now we have 3x equals 1 over 3 to the third. Now, just like that last one, if you see fractions involved, it's probably a negative. And sure enough, if I want to bring this upstairs, I would have 3 to the x power equals 3. And because it's positive downstairs, I'm taking that attitude and I'm changing it by moving it upstairs. So now I've got negative 3 here. Get rid of those same bases and you have x equals negative 3. Sure enough, if we go and plug that back in, 3 to the negative 3 power would in fact give us 1 over 27. Good. All right, let's try another one. And I like different colors of pens, so we're just going to use a different pen. So log base 7 of 7 equals, and I went ahead and slapped on an x there so that I can use my little snail method. Just like that, 7 to the x power equals 7. This one looks a little tricky. Remember, part of our invisible math is if an exponent isn't shown, it's a 1. So hopefully that helps you out, because now you can cross out those same bases and you're left with x equals 1. So this is a really good one to remember. For your notes, put this in your notes and throw a star by it. If you have log base a of a equals b up here, all of that equals b, because this cancels out with this. Okay, so that's a good rule, because we just showed that rule, right? These guys cancel out and we're left with 1. Okay, log base 5 of 1. Let's go ahead and slap on an x there, equals x. Use our little snail method. 5 to the x power equals 1. 5 to the x power equals 1. Okay, so we need a same base, right? That's been the whole part of solving these, is that we need the same base. What can I put here? 5, so we'll do 5 to the x power equals 5 to the what power will give me 1? Tricky, tricky. If you said 0, you are absolutely correct, because anything to the 0 power is 1. So now that we have those same bases, we can get rid of those and we say x equals 0. And sure enough, if we plug that back in, 5 to the 0 power equals 1. Hopefully you've learned something new in this lesson, and I look forward to seeing you next time.